Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular video is November 2018, Paper 3, Foundation Tier. Now, with the new specification being new, Grade 9 to 1 past papers are like gold dust, and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback, and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. Welcome along to another AQA GCSE Mathematics past paper walkthrough. Today we're looking at November 2018, Paper 3, Foundation Tier. Question 1. Add 8 millimeters to 7 centimeters. So we've got some addition here, but we've got some mixed units. We've got metric units, and we should know that 1 centimeter is the same thing as 10 millimeters. So if you've got something in centimeters, if you multiply it by 10, you'll get millimeters. So 7 centimeters is the same thing as 70 millimeters. So 8 millimeters and 70 millimeters, 8 plus 70 is going to give you 78 millimeters. Now that's not any of my answers there, is it? But I've got one here which is 7.8 centimeters. So if I know that 10 millimeters is 1 centimeter, I can convert this back the other way, can't I? So 7.8 centimeters is the answer. Question 2. In a pie chart, one sector represents 1/4 of the data. What is the angle of that sector? Circle your answer. So if you imagine you've got a circle, then 1/4 of it, this amount, if that's the pie chart, what's the angle in the center there? It's going to be a right angle, isn't it? So it's 90 degrees. Is that one there? Question 3. Which of these cannot be the number of lines of symmetry of a triangle? Circle your answer. 0, 1, 2, or 3. Now, I can draw a triangle with no lines of symmetry. We can just draw a scalene triangle where each side is a different length. Something like that. That one has got no lines of symmetry. So 0 is possible. I could, for one line of symmetry, I could draw a isosceles triangle, couldn't I? That's got one line of symmetry down the middle, so 1 is possible. Is 2 possible? Well, I know that 3 is possible, because if I've got an equilateral triangle, then I've got 3 lines of symmetry, haven't I? Okay, so that one's possible. I think it must be 2. I think if you've got 2, then you must have a third one, so it's not possible just to have 2 lines of symmetry by itself. So that's the one that cannot be. Question 4. Circle the fraction equal to 0.12. Okay, so if you remember from place values, this is units. The first digit after the decimal place is tenths, and then the second digit is 100ths, isn't it? So we've got 1/10 and 200ths, or in other words, we've got 12 100ths. So 0.12 is the same thing as 12 over 100. Is that any of my answers? Nope. But can I cancel this down so it is equal to one of those? So looking for common divisors for 12 and 100. Well, 12 is in the 4 times table, isn't it? 4, 8, 12, and so is 100. So I can divide both by 4. That should give me 3 over 25, which is that one there. You can also cancel this down. It's a calculator paper, isn't it? So I could just cancel it down on the calculator as well. If I just type into the calculator 12 over 100, that's going to cancel it down for me straight away, isn't it? So that's another way of doing it. Question 5a. Solve n plus 7 is equal to 103. Okay, so doing the same thing to both sides. If I subtract 7 from there and I subtract 7 from there, what have I got? So n plus 7 take away 7 is going to leave me with the n. 103 take away the 7 is going to give me 96. So n is equal to 96. That was fairly easy. Right, what does part B say? Solve m divided by 6 is equal to 12. Okay, so again, keeping this idea of doing the same thing to both sides. If I multiply both sides by 6, that will cancel with that, and it will just leave me with m on the left-hand side. 12 times 6 is 72, isn't it? So m is equal to 72. Question 6. Here is a plan of a flat with 4 rectangular rooms. And we're told on the grid on the opposite page, make an accurate scale drawing of the plan. Label each room and use a scale of 1 centimeter to represent 2 feet. Okay, so we've got a grid on the opposite side, but before we move over there, let's convert all of these feet into the centimeters it needs to be on my diagram. So if 1 centimeter represents 2 feet, if I divide each of these numbers by 2, it should tell me how many centimeters I need to draw. So my 8 feet, 8 divided by 2, that's going to be 4 centimeters. 12 feet is going to be 6 centimeters. 8 feet is going to be 4 centimeters. 14 feet is going to be 7 centimeters. 10 feet is going to be 5 centimeters. And 6 feet is going to be 3 centimeters. So knowing that, we should be able to draw this sketch then. So first off, the bathroom, which is 3 centimeters by 4 centimeters. Let's draw our bathroom, which is going to be 3 centimeters by 4 centimeters. Have I got a pencil here? Pencil. Let's use a red pencil so it stands out a bit. So 3 centimeters by 4 centimeters is going to be our bathroom. Okay, let's just finish that off. 3 by 4. Let's label that bathroom. Now underneath the bathroom was, so we've done that one there, haven't we? So next underneath the bathroom is a bedroom. That should be 5 centimeters by 4 centimeters. So let's add that on next. Well, the 4 is already drawn, isn't it? So I just need to draw the 5 underneath. So that's the bedroom. What's next? Okay, so I've done the bathroom and the bedroom. Next is the kitchen. That is 6 by 4. So 6 along, 4 down. 6 along. 1, 2, 3, 4, 5, 6 along. 4 down. That was the kitchen. And then finally we had the living room, which was 6 by 7. So we've already got the 6 of the length drawn, so we just need to draw kind of a width of 7. So counting down 1, 2, 3, 4, 5, 6, 7. Oops. And so that is the living room, isn't it? Living room, all done. Okay, so there's my plan. Question 7. Here are two groups of numbers A and B. One number is moved from A to B. The sum of the numbers in B is now 20 more than the sum of the numbers in A. Which number is moved? You must show your working. Now, I'm not altogether clear which number I need to move yet. I think that probably the easiest thing to do first is just add up those numbers first from the two boxes to see what we've got to start with. So before we move it, what are the totals? Well, I've got 19 plus 11 plus 14 plus 32 plus 16 plus 9, and that comes to 101. So it starts off, group A starts at being 101. Group B, what have I got? I've got 31 plus 18 plus 28 plus 12. That comes to 89. So at this point then, what's the difference between them? 101 take away 89. They've got a difference of 12. Okay, now we want to make a difference of 20. Okay, but actually the difference here, at the moment, group B is actually minus 12, isn't it? Because it's 12 less than group A. We want it to be positive 20, which is 20 more than group A. Okay, so which one do we need to move? Now, the difference then between minus 12 and 20 is 32. So you might think it's the 32 that you need to move over, but actually that is not the case, because if I move the 32 over, 101 take away 32 is going to be, what, 69, and 89 plus 32 is going to be 121. Now the difference between those two is not then 20, as you can see. What you have to do is not take off the 32, which is the difference between these two numbers. I need to take off half of that. So I need to take off the 16, or move the 16. So if I move the 16, group A is going to be 16 less, and group B is going to be 16 more, so that's going to make a difference of 32 between the two of them. Okay, so moving the 16 over, 89 plus 16 is now giving me 99, 105, and 101 take away 16 is going to be 95, 85, isn't it? So the difference between 85 and 105, you can see, is 20. So that was after. Okay, now it says you must show your working. I kind of have. Maybe to be totally clear, maybe I could just write that down as a sum down here, so it's nice and clear what I've done. So before, I had group A, which was 19 plus 11 plus 14 plus 32 plus 16 plus 9, and that came to, what did we say, 101. It was 101, and group B, that's going to be 31 and 18 and 28 and 12, and that came to, we said it was 89, didn't we? 89, giving us a difference of, we said it was minus 12. And then after, well, then we can just do the same thing again, but with the 16 removed. So I've got 19 plus 11 plus 14 plus 32 plus 9 coming to 85, and group B, which has got 31 and 18 and 28 and 12 plus my new 16, giving me a total of 105. So the difference there is 20 as requested. Okay, I think that's probably more than is required. I think probably there's enough information there in the diagram, but just want to be sure I've got enough method down, because it does say I must show my working. Okay, just make sure I finish that off as well by saying which number is moved. The number that was moved was 16, wasn't it? 16 was moved, making sure we actually answer the question. Question 8. Beth sells hot dogs at a market. Each hot dog is a sausage in a bread roll. Hot dogs £3 each. The table shows her costs. Fees paid to the market £240. Bread rolls 42p per pack of 6. Sausages £2.50 per jar of 10. Other costs £57. Now it says that Beth sells the hot dogs for £3 each, and she sells 300 hot dogs. And we need to work out her total profit. Okay, well, our total profit is going to be total income minus total expenditure. So your money coming in less your money coming out. So we need to work out those two amounts, don't we? So let's work out income first. How much money she's got coming in. So we know how much money she's coming in from this part down here, don't we? Okay, so that's where we get our income from. Beth sells hot dogs for £3 each, and she sells 300 hot dogs. So that's quite simple. So income is going to be her £3 per hot dog times her 300 hot dogs. 3 times 300 is £900. So that was nice and easy. What about expenditure? So that was money coming in. What about money going out? Expenditure. So what has she got? So her total expenditure then is going to be the £240 from the fee paid to the market. She's got 42p per pack of 6 bread rolls. So how many bread rolls is she going to need then? If she's made 300 hot dogs and bread rolls are in packs of 6, then what's 300 divided by 6? 6's into 300 go 50 times, so she's going to need 50 packs of those bread rolls. So that's going to be 50 times 0.42. Okay. Sausages, £2.50 per jar of 10. So 300 divided by 10 means I need 30 jars of sausages. So I need 30 jars at £2.50 each. And I've got 57 other costs. Okay, so then in total then, my total expenditure is going to be 240 plus 50 lots of 42 pence. So 50 times 0.42, that comes out to be £21. I've got 30 lots of £2.50. 30 times £2.50, that comes out to be £75. So my total expenditure is going to be those 4 amounts added up, then, isn't it? So expenditure then is going to be 240 plus the 21 plus the 75 plus the 56. 24, 240, 21, 75, sorry, 57. £57 in other expenditure, which comes to 240 plus 21 plus 75 plus 57. That means total expenditure is £393. Okay, so what's her profit then? So profit is going to be income less expenditure, which is going to be her £900 that she made less the £393 that she spent. That comes out to be £507. So she's made a good profit on those hot dogs. £507. Question 9. A company sells houses. The line graph shows the number sold per week for 30 weeks. So I've got number of weeks on the y-axis and number of houses on the x-axis. We need to work out the range of the number of houses sold per week. Now range is equal to highest subtract lowest. The highest number of houses sold is going to be 5, isn't it? And then the lowest number of houses sold is going to be 0. So then the range of number of houses sold is going to be 5, the highest, minus 0, the lowest, which is 5. Okay, the next it says work out the median number of houses sold per week. Now median is the middle number, isn't it? Okay, is that easy to do from here? We've got 30 weeks altogether, so the median value is going to be what, 30 plus 1 over 2. It's going to be the 15.5 value. Okay, now I've got the first 2 in that first bar there, the next 3 in there, next 4 in there, giving me a total of 6 so far, and then 3 in that one, giving me 9 altogether, plus 6 in there, taking me to 15, and then the 16th person is going to be in the 4 group, isn't it? Okay, so my median then is going to be halfway between this one and this one. So my median is going to be 3 plus 4 over 2, the average of those two. So the median is going to be 3 plus 4 over 2, which is 3.5. So it's 3.5 houses sold per week is the median. 9C says the company sells 3 houses. The prices are 185,000, 239,000 and 136,000. The company earns a 2% commission on each house. In total, how much commission does the company earn on the 3 houses? Okay, so we're going to have to take each one of these amounts then, 185,000, and times it by 0.02 then to find the percentage. So 185,000 times 0.02, that comes to 3,700. 3,700. The next one, 239,000. Also 0.02% of that. What's that going to be then? 239,000 times 0.02. That's 4,780. And then 136,000 times 0.02. That comes to be 2,720. Okay, I'm going to add up then all the commissions they made. You could have also just added up the cost of the 3 houses and found 2% of that. That would have also worked. It might actually been slightly quicker as well. I make that 11,200. Okay, so that's my final answer. £11,200. Question 10. In a game, a fair spinner has 5 equal sections as shown. One says miss a turn, one says go forward 2 squares, one says go back 1 square, one says go forward 2 squares, and one says go forward 5 squares. They all look about equal in size, so it looks like it might be a 1 in 5 chance of getting each of those. Chloe spins a spinner. Write down the probability that she gets miss a turn. Now, probability is equal to successful outcomes divided by total outcomes. Now here, success is miss a turn, and there's one of those on the dice, and there are a total of, not on the dice, on the spinner, and there are a total of 5 equally sized areas on the spinner. So the probability then she gets miss a turn is going to be 1 in 5. Part B says the spinner lands on go back 1 square 3 times in a row. Jamal is to spin next. Write down the probability that he gets go back 1 square. Okay. Now, if you have a look at this, he got go back 1 square 3 times in a row. Now, that is unlikely to happen, isn't it? Getting the same thing 3 times in a row. But actually, it doesn't change the probability of his next throw. It doesn't make it any more or less likely that he's going to get it than it wasn't any of his previous throws. So the probability he's going to get go back 1 square on his next throw is still going to be the same as it was in the last 3. It's still going to be 1 chance in 5. Okay? Question 10c. In one game there are 85 spins. How many of these spins are expected to be go forward 2 squares? Now, expected successes, or the expected number of successes, is going to be equal to the number of trials times the probability of success. Okay, and in this case there are 85 spins, so there are 85 events happening, or 85 trials, and the probability of success, now there are actually 2 parts of the spinner that are labelled go forward 2 spaces, so that's 2/5 then, isn't it? So 85 times 2/5, so 85 times 2 divided by 5 comes to 34. I'd expect there to be 34 go forward 2 squares. 34. Question 11. Circle the cube number. Now, I do recommend that you learn the first 10 cube numbers ready for your exams. If you have, it could be easy enough for you to pick out the cube number in this list. It's that one there, 729, which you should remember is 9 cubed. Okay, what's part 12 say? 12, how many minutes is 225 seconds? Now, there are 60 minutes in 60 seconds in a minute, sorry. So 60, 120, 180, that's 3 minutes, isn't it? And then 240 I've gone over. So it's not quite 4 minutes, it's 3 minutes and something. So it's not that one, and it's not that one. So is it 3 minutes and a quarter, or is it 3 minutes and 3/4? Well, like we said, 60, 120, 180, 240 is bust. So what's the difference between 180 and 225? So it's going to go in 3 times with a remainder of 225 take away 180 is 45. So 45/60. So it's 3 minutes and 45/60 of a minute, which is the same thing as 3 3/4. It's that one. Question 13. A small square has a length of x centimeters and a large square has a length of 15 centimeters. The area of the small square is 1/9 of the area of the large square. Work out the value of x. Okay, so let's have a look at the big square first. If it's got a length of 15, then it also has a width of 15 because it's a square. So the area of the square is going to be 15 times 15, isn't it? Now, 15 times 15 is 225. Oops, 225. Okay, so the area of the small square is 1/9 of the area of the large square. So if this big square is 225, then the small square is going to be 225 divided by 9. 225 divided by 9 is 25. So then x then is going to be the square root of 25. So x equals the root of 25, which is 5 centimeters, isn't it? Okay, so the answer is x is equal to 5 centimeters. Question 14. The term-to-term rule of a sequence is add 8 and then divide by 2. Now we're told that the first term of the sequence is minus 24. We need to work out what the next 2 terms are. Okay, so to get the next one, I need to add 8 and then divide by 2 then, don't I? So minus 24 plus 8, what's that then? Negative 24 plus 8, that comes out to be negative 16, and negative 16 divided by 2 is negative 8. So negative 8 is going to be my second term, and then my third term is going to be minus 8 plus 8 divided by 2. So take negative 8, add 8 first, negative 8 plus 8 is 0, and then divide 0 by 2. That is also equal to 0. So minus 8 followed by 0. Okay, B, the term-to-term rule of a different sequence is subtract 1 and multiply by 5. Now this time we've been given the third term of the sequence, which is 120, and we need to kind of work backwards to work out what the first term is. Okay? So this is a subtract 1 and multiply by 5 sequence. So if we were going to draw this as a function machine, it would be a subtract 1 followed by a times by 5 function machine, wouldn't it? Okay, so take our input number, subtract 1 and then times it by 5. Now if I want to work through the other way, if I'm going to go backwards, I'm going to do the opposite of that then, aren't I? So going this way, I'm going to divide by 5 and I'm going to add 1. Okay? And that will give me my original number back. So if I take 120 and I divide it by 5 and then I add 1, what do I get? 120 divided by 5, 120 divided by 5 comes out to be 24, and then add 1 is 25. So that means the second term must be 25. I'm going to do the same thing again. 25 divided by 5 plus 1. So 25 divided by 5 is 5 plus 1 is 6. So that means my first term must have been 6, and then 25 and then 120. Now if you wanted to, you could then just double check by working back this way to be doubly sure. So 6 subtract 1 is 5 times 5 is 25. 25 subtract 1 is 24 times 5 is 120. So you can just double check it going back the other way. But my answer is, what is the first term? It's 6. Question 15. Describe fully the single transformation that maps shape A to shape B. Okay, so single is in bold, which means we need to come up with one move to take A and map it onto B. Now, I from sight can see already what that's going to be. I think it's going to be a rotation. Okay, but to describe fully a rotation, you need to mention 3 things. You need to say it's a rotation, you need to say where the center of rotation is, and you also need to say what the angle of rotation is. Okay, so, and you'll notice that that corresponds with the 3 marks of this question. So to fully describe this transformation, my first mark is going to come from the fact that I say it's a rotation. I need to mention what the center of rotation is, and I need to say what the angle of rotation is. So now I think the easiest way to do this is to ask for a piece of tracing paper. So get a piece of tracing paper, lay it over the top, then just sketch your triangle A that you want to transform, and then make a reasonable guess of where the center of rotation is going to be. Most likely it's going to be on one of the axes or one of the corners of the shape, but you can just try a few and experiment until you find the right one. And with a few goes, you should be able to find that it's the origin is the center of rotation. So if you put your pen or your pencil tip here at the origin and then turn it, you'll find that A lies then exactly on top of B. Okay, so the center is going to be the origin, or 0, 0, and the angle of rotation, well, it's rotating 1/4 turn, isn't it? So it's a 90-degree angle that is turning. And which way around is that? Clockwise or anti-clockwise? Well, you can always look at the clock on the wall of your exam room to remember which way around clocks go. This one is definitely going in the opposite direction to clocks. So we say that this is anti-clockwise. So a 3-mark question this. Now to get each of the marks you need those 3 things. Rotation, 1 mark. Center, 1 mark. Angle, 1 mark. Okay. Let's move on. Question 16. Amal drives her car for work. She claims 40p per mile from her employer. Amal's car travels 52 miles for each gallon of petrol. She pays £5.36 for a gallon of petrol. On one journey, Amal drives 260 miles. For this journey, how much more does she claim than she pays for the petrol? Okay, so we need to work out how much she gets coming in for her allowance, and we need to work out how much it actually costs her, and then take one away from the other to find out what she's earned or what the difference is between those two. Okay, so let's start off with the amount of money that the employer pays. So what does the employer pay? So the employer pays, what does the employer pay? The employer pays 40p per mile. Okay, so if she's travelled 260 miles, then that's going to be equal to 260 miles times by 40 pence. I'm just going to write that down as pounds, so 0.40. So tap that into the calculator. 260 miles times by 0.4, that gives me £104. So she gets paid by the employer £104 for driving that amount of distance in her car. Now let's work out how much it actually costs. So she's got 260 miles. Now she can travel 52 miles for each gallon of petrol. So if she takes the amount of miles that she's travelled and divide it by 52, that will tell you how many gallons of petrol that she's going to need in order to drive that distance. Make sense? Okay, once we've worked out how many gallons of petrol she needs, I just then need to multiply then by the cost of each gallon of petrol, which is £5.36, to get the total. So 260 was the number of miles that she's travelled. She's getting 52 miles per each gallon of petrol, so I'm dividing by 52 and I'm timesing by the cost of each gallon, which is £5.36. So tapping that into the calculator, 260 divided by 52 and then times that by £5.36, that comes out to be £26.80. Okay, so for this journey, how much more does she claim than she pays for in petrol? So then we need to work out one, take away the other then. So how much more? Is equal to what she claimed minus how much she got. Okay, so 104 minus 26.8. That comes out to be £77.20. Oops. So she's actually been paid £77.20 more than she paid for the cost of the petrol of the journey. So on first look of it, it might seem like she's actually getting a really good deal out of this then, because the employer is paying her £104 and she's only paid £26.80 in petrol. So that's an extra £77.20 she's got coming in. But you do have to remember, when you're driving a car, there are lots of other costs involved. You know, you have to actually buy the car yourself to start with. You need to insure it and tax it, and there's wear and tear on the car as well. You can only get so many miles out of a set of tyres, stuff like that. So there are a lot of extra costs, lots of hidden costs in driving a car. So whilst it might seem that she's making lots and lots of money out of doing this, you might find that once you've worked out all the other on costs, there isn't a lot of difference in it. Anyway, let's move on. Question 17. Here is a map of Cuba. 1.5 centimeters represents 200 kilometers. Okay, so there's my scale there. 0 to 200 kilometers is there. It's 1.5 centimeters. Work out the actual distance from Havana to Holguin. I don't know if I'm saying that right. Holguin. Okay, so Havana to Holguin. So getting a ruler and measuring the distance between these two. Now you see that my ruler doesn't have a scale on it, which is a slight problem. So I think I'm going to have to just refer to the mark scheme to find out what the actual distance is, because my virtual ruler is not going to tell me. Also, if you're using a kind of a practice paper from your school, which they printed out for you, they often print these at a slightly different scale from the original papers, so often they're a little bit out compared to the mark scheme as well, so just bear that in mind. Right, so according to the mark scheme, that distance should be 4.7 centimeters. Okay, it might give you a little bit of leeway, like a plus or minus a millimeter on that distance, but you should get something close to 4.7 centimeters as your distance. So I know that for every 1.5 centimeters, that's 200 kilometers. So if I take my 4.7 centimeters, divide it by 1.5, okay, that tells me how many 1.5s I've got, and each one of those 1.5s is worth 200. Okay, so it's 4.7 divided by 1.5 times by 200. 4.7 divided by 1.5 times by 200 should give me a distance of 626.6 reoccurring kilometers. I'm just going to round that off. I'm going to round it off to 627. 627 kilometers. Question 18. 4 friends all give each other presents. The total cost of the presents is £83.40. Work out the mean cost of a present. Okay, so the mean cost is going to be the total cost of the presents, which I already know. It's £83.40 divided by the number of presents. Do I know that? Got 4 friends. When I first read this, I just thought this is a really easy question. Four presents. £83.40, just divide that by 4, but that isn't quite right, is it? It says 4 friends all give each other presents. So if I've got 4 friends, so friend 1, friend 2, friend 3, friend 4, then friend 1 over here, this chummy here, is going to give him a present, her a present, and him or her a present over there. So he's actually going to give 3 presents out. Friend 2 is going to do the same thing, isn't he? She's going to give one there, one there, one there. So that's another 3. So 3, 6. Friend 3 is going to give a present there, present there, present there. So she's going to give out 3 presents. And same for person 4. So actually, you've got 4 friends each giving out 3 presents. So the total number of presents given out then is 12 and not 4. So there's 12 presents altogether. £83.40 to divide by 12. What's that then? 83.4 divided by 12. That comes out to be £6.95. Okay. I might just write down that. So I've got 4 friends. Each give 3 presents. 4 times 3 is 12, just to show my method there for working out 12. Okay, and then, so that's it, £6.95 is the answer, isn't it? £6.95, that's actually quite easy. Question 19. A forest has 6,500 trees. The trees are beech or maple. The number of beech to the number of maple is in the ratio of 1.6 to 1. What fraction of the trees are beech? Okay, so the ratio is 1.6 to 1. So if I added those 2 bits together, 1.6 plus 1, that gives me a total of 2.6. So what fraction of the trees are beech? It's going to be this 1.6 divided by this 2.6 here, isn't it? So it's 1.6 over 2.6. Don't normally write fractions with decimal points in there. Let's try multiplying top and bottom by 10. So that's going to give me 16 over 26. Any fractions, top and bottom, any common divisors? Well, they're both even numbers, aren't they? So that's 8 over 13. 13 is prime, so I don't think I'm going to be able to cancel it down any more than that. So my answer is 8/13. Right, next part says, write the number of beech to the number of maple in the form 1 to n. Okay, well at the moment I've got 1.6 to 1. So if I want to make that first number into a 1 and not a 1.6, I'm going to have to divide by 1.6, and if I divide 1.6 that side, I need to divide 1.6 this side as well. So what is 1 divided by 1.6? Apparently that's 5/8. So that's 1 to 5/8. So in the form of 1 to n is 1 to 5/8. Could write that down as a decimal as well, but I think fractions look nice. Going to leave it like that. A shape is translated by the vector 0, 4. In which direction does the shape move? Circle your answer. Okay, so vectors, common vectors, are always given in the form of x over y, like that. So the top number, the 0, is how far it's moved in the x direction, and the bottom number, the y number, is how far it's moved in the y direction. So in this case, we're moving 4 units in the direction of y, so 4 units up, and 0 units in the direction of x. So the shape is going to translate upwards. The length of a table is 110 centimeters to the nearest centimeter. Complete the error interval. Okay, so I tend to draw a line when I do these, and I mark the number I've been given. Now this is to the nearest centimeter. So on my scale, I'm going to go up 1 centimeter, so that would be 111, and down 1 centimeter, that would be 109. Now the numbers that round to 110 are the numbers that are going to be halfway or closer to 110. So it's all these numbers in here. These are the ones that round to 110, aren't they? And halfway between 109 and 110 is 109.5, and halfway between 110 and 111 is 110.5. So they're going to be my boundaries. Now notice really 110.5 would round up, which is why you've got this strictly less than sign in here. We're told that k equals n squared plus 9n plus 1. Mo says k will be a prime number for all integer values of n from 1 to 9. Show that Mo is wrong. You must show that your value of k is not a prime. Okay, so let's just start off by generating some values for k. So I'm going to make a little table of values. So I've got my input values, which are n, and my output values then, which are k then, aren't they? So n can be any number between 1 and 9, like 1, 2, 3, 4, 5, 6, 7, 8, 9. Don't know if I'm going to have to do the whole table. Right, so what's the value of k then? If n is 1, then k is 1 squared plus 9 lots of 1 plus 1. Okay, so when n is 1, then k is going to be 1 squared plus 9 lots of 1 plus 1. So 1 squared is 1, 9 lots of 1 is 9, and 1 is 1. So that adds up to 11. Okay, so when n is 1, k is 11. Now, 11 is a prime, isn't it? So that one's fine. I'm going to have to keep going until I find a not prime, I think. So 2 squared plus 9 lots of 2 plus 1. So 2 squared is 4, 9 lots of 2 is 18, and 1. So 22, 23. 23 is also a prime. N is 3. What's k then? K is going to be 3 squared plus 9 lots of 3 plus 1. I don't have to do too many of these. So 9 plus 27, which is 36, plus 1, which is 37, which I think is also prime. About 4, n is 4. So k is 4 squared plus 9 lots of 4 plus 1. So 4 squared is 16. 9 lots of 4 is 36. 16 and 36. 46, 52 plus 1 is 53, which I think annoyingly might also be a prime. 5. So what have we got there then? K is equal to 5 squared plus 9 lots of 5 plus 1. So 25 and 45, 50, 70 plus 1 is 71. 71 prime? I think it might be. So what else we got? 6, k equals 6 squared plus 9 lots of 6 plus 1. 36 and 9 sixes are 54. So 54 and 36. That makes 91. Is 91 prime? No, 91, I'm not sure that is a prime, you know. 91. Well, it's in the 7 times table, isn't it? 70 take away from 91 is 21, and 21 is also in the 7 times table. So I think that 91 is 7 times 13. So clearly we haven't got all primes here. Did quite well up until that point, but 91 is not prime. So that's my, I've showed that the value of k is not prime for one of the values because I've shown a factor pair of it. So that's good. So 91 equals 7 times 3, so not prime. I think I just write at the front here, n equals 6, k equals 91, which is 7 times 13, so not prime. Okay, happy with that? Let's move on. Question 23. At a cafe, 2 teas and 1 coffee cost £3.40, and 1 tea and 4 coffees cost £7.30. Work out the cost of 1 tea and 1 coffee. Now, this is actually a pair of simultaneous linear equations. It's just written out in words. If I said the cost of a cup of tea was T and the cost of a cup of coffee was C, I could rewrite this as a pair of linear equations. So I've got 2 T's plus 1 C, which I'm just going to write down as C because I don't write 1 C. So 2T plus C, that equals 3.4 or 3.40, £3.40. And I've got 1 T plus 4 C, 4 coffees, and that equals to 7.30. Okay, so that's my pair of linear equations. Now, what you need to do then is try and find a way of cancelling one of them out. If I call this one equation 1 and this one equation 2, and I multiply, oops. Now, if I try and cancel t's, I would have to make this second one twice as big, wouldn't I? So I've got 2 t's on both. Okay, I'm going to put that one at the top. So I'm going to have equation 2 multiplied by 2, and then I'm going to subtract from that equation 1. Okay, so take equation 2 and just double everything up. So I've got 2t plus 8c is equal to 2 lots of £7.30 is £14.60. Now you should just notice I've taken each one of these lines here, multiplied everything by 2 to get 2t plus 8c is 14.6. And then I'm going to subtract equation 1, just going to leave that one as it is. 2t plus c is equal to 3.40. Now you should see now I've got the same number of t's, so 2t subtract 2t, they're going to cancel each other out, leaving 0. 8c take away c is going to give me 7c. And £14.60 take away £3.40 is going to give me £11.20. So that tells me that 7 cups of coffee costs £11.20. So then I can work out the cost of 1 cup of coffee by taking my £11.20 and dividing it by 7. So what's that? £11.20 divided by 7 is £1.60. Okay, so coffees cost £1.60. Once I know that, I should be able to work out the cost of teas. So I can do that by substituting into one of my other equations. So let's substitute C equals £1.60 into one of my original equations. Let's put it into equation 1. Okay, so 2t plus c equals £3.40. So 2t plus c, which we now know is £1.60, that's equal to £3.40. Okay, so subtracting £1.60 from both sides tells me that 2t's costs £3.40, take away £1.60, that's £2.40, £1.80, isn't it? So 2t's is £1.80. So then dividing both sides by 2 should tell me that t is equal to 90p. Okay, so t is 90p and coffee is £1.60. Okay, t is 90p, coffee is £1.60. A music festival has taken place each year from 2011. The table shows the number of people who attended each year. So I've got years 2011 up to 2018 and the corresponding number of people. And you can see it's generally going upwards. It's an upward trend there, isn't there? The festival organisers draw a time series graph to represent the data. The first 4 years have been plotted. Okay, so basically they're just plotting the year against the number of people, aren't they? That's what that time series is. Okay, what are the questions? Oh, complete the graph. Okay, so we've got 4 of the points down. So we've done 2011, 12, 13, 14 are all done. So we need to, next is to plot this one here, 2015 against 2023. Okay, let's have a quick look at our scale. You can see the distance between one big square like that is 500 units, and there are 5 little divisions between. So each division is going to be 100 then, isn't it? So then if I want to plot 2023, well, 2000 would be on the main line. 2100 would be the next little square up. So our point is going to be fractionally above the 2000 line. So something like that. Next point, 2016 against 2612. 2500, so one little square above 2500 is going to be 2600, which is pretty much where I'm going to plot that one. And then I've got 2017 against 3251, so I'm going to kind of plot it halfway between the 2 little squares there then. So 3001, 2, so kind of halfway, because it's and 50, isn't it? So it should be there. And then finally 2018, 3780. So 3700 is the second square up, but it's an 80, so it might be quite clear, quite close to the third line. Okay, so notice in the first part of the graph they've joined them together with a ruler. So I'm just going to copy that for the remainder of my diagram. Not convinced time series was on the specification, but they've shown me how it works. I'm just copying what it looks like, copying their pattern up the diagram like that. So there we go, that's all done. Okay, what now? Use the graph to estimate the number of people who will attend the festival in 2019. Okay. So we can see that there's a general upward trend of this line. It's kind of going like that, isn't it? So I would suggest that if we kind of continued this line up, then it would cross about there then, won't it? What's that value there? That would be 2019 on my X scale. My Y scale, okay, why don't we read up and a read across, show our method. Okay, so on my scale, I'm reading that as like between 4,300 and 4,400. So I'm going to estimate halfway between, so 4,350, something like that. So I'm going to estimate 4,350. Don't have to write anything here. My method is on the diagram. Doug owes an amount of £600. He wants to pay off this amount in 5 months. He says, each month I will pay back 20% of the amount I still owe. Show working to check if his method is correct. I don't think this is going to work, Doug. If you're just paying back 20% of what you still owe, this is a kind of never-ending sum, isn't it? Basically, it's like compound interest, isn't it? So you've got, for percentages, final, original, multiplier. The final is what we're trying to find here. The original is 600, and the multiplier, so if he's paying back 20%, then he's retaining 80% of the value then, isn't he? So you're basically timesing through by 0.8 each time. So after 5 months of paying back 20%, your final then equals original times multiplier, which is 600 times 0.8, but we're doing this 5 times, aren't we? So it's to the power of 5. So after 5 months, how much will be left? 600 times 0.8 to the power of 5. That gives me £196.61. That's remaining to be paid, isn't it? So he has not cleared the £600. Okay, I think I'm just going to sign off like that. So I've shown it, haven't I? Question 26. Here is a quadratic graph. It says circle the x-coordinate of the turning point of the graph. Now the turning point is like the lowest point on the curve. It's going to be this point here at the bottom of the curve. Now that's the x-coordinate there on the x-axis, and this is its y-coordinate. So this is the coordinate 1, minus 4, but it just asked me for the x-coordinate, doesn't it, which is this part, this 1 here. So it's just 1. A motor racing circuit consists of 2 parallel straight sections, each of length 0.75 kilometers, a semicircle of diameter 0.9 kilometers, and 3 equal smaller semicircles. Okay, we've got a diagram for it here. Are all the measurements on there? We're told, I think just this, the 3 equal smaller semicircles is missing, isn't it? So if it's 0.9 meters from here to here, then the diameter of each one of these smaller circles then is going to be 1/3 of that. So the distance from there to there, and similarly on the other 3, is going to be 1/3 of 0.9. It's going to be 0.3. So just as a bit of a top tip, do make sure you read through all this information at the top of the question carefully, and just check that all the information that's given written like that in the instructions are actually on the diagram. Anyway, let's move on. The length of the motor race must be greater than 305 kilometers. What is the lowest number of full laps needed at this circuit? You must show your working. Okay, so we need to know, well, basically we need to know the perimeter of this shape, don't we? Okay, so these bits here are no problem. That's 75, 0.75 and 0.75. We then need to work out this part of a circle here, and then we're going to have to work out this part of a circle and times it by 3, aren't we? Okay, should we do that then? So let's do the area of, so the perimeter of this one. I suppose this bit here then, this arc length, is going to be half of pi r, no, not pi r squared, pi d, isn't it? pi times diameter. Half pi times d. Here the diameter is 0.9. So that's going to be half pi 0.9. What's half pi 0.9? 0.45 pi, isn't it? I'll leave the pi in for now. And then on the other side, I've got a diameter of 0.3. So that's half of pi times the diameter of 0.3, which is 0.15 pi. But I've got 3 of those, haven't I? So then the total length of this course then, length of one lap then is going to be my 2 lots of 0.75 kilometers, my 0.45 pi for the larger semicircle, and 3 lots of 0.15 pi for my 3 smaller semicircles. Okay. Well, 3 lots of 0.15 is 0.45, and 0.45 plus 0.45 is 0.9. So actually, 2 times 0.75 is 1.5. And my 0.45 pi and my 0.45 pi gives me plus 0.9 pi. So what's that then? 1.5 plus 0.9 times pi comes out to be 4.327. I'm going to just write that down as 4.33. But when I am calculating on, I need to calculate on, so I'll just use the full calculator value. So that's what one lap is. Now, if you remember, we needed to make the race greater than 305 kilometers. So if I then divide the length of one lap into 305, I should work out how many laps I need. So number of laps is going to be 305 kilometers divided by our course length of 4.33 kilometers. So let's work out how many times that goes in then. So on the calculator, 305 divided by my last answer comes out to be 70.5. So that equals 70.5. But I can't have 70.5 laps. I need to have full laps, it says in the question. So I'm going to have to round that up. So in total, that means there are 71 laps. Solve 8 is greater than 3 minus a half of x. Now, linear inequalities you can solve the same way as you would an equation. So here I've got 3 minus a half x. Just to make that positive, I might just move it to the other side of the equation. So take that and move it over to this side. Or another way of thinking about it is add in a half x to both sides. So it would disappear on the right and reappear on the left. And at the same time, I'm going to subtract 8 from that side and move it to the other side. So I'm going to get a half x is greater than 3 subtract 8. Okay, so what does that give me? So half x is greater than 3 subtract 8 is minus 5. And then times in both sides by 2 to get rid of the half. I'm going to get x is greater than minus 10. Okay, so that's my answer. X is greater than minus 10. Use trigonometry to work out the size of angle x. Okay, right, so trigonometry is a right angled triangle, so it's about Soccer, isn't it? Is that how you remember it? Now, easiest thing to do is just label up the sides first. Here's my angle down here. So that means, well, that's the longest side, isn't it? So it's the hypotenuse. This 9 joins onto it, so it's the adjacent, and that makes the other side the opposite. So I have been given the adjacent and the hypotenuse, and I want x. So the ratio that includes the adjacent and the hypotenuse is that one there. Cosine. So let's write that out fully then. The cosine of an angle is equal to the adjacent divided by the hypotenuse. Okay, that's the full ratio that we need to use. So then let's sub in what we know. Cos, well, it's x in this case, not theta. Adjacent is 9 and the hypotenuse is 10. Okay, so the cos of x is 9/10. So then x is going to be the inverse cosine of 9/10. Okay, so that, reaching for the calculator, shift cos 9 divided by 10 comes out to 25.84, which we're just going to round off to one decimal place, 25.8. So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.